Thank you, Akihiro. I'm going to take the opportunity this afternoon to introduce some new concepts as we continue to try to understand and unravel the mucosal immunity. We're starting to actually discover some very interesting trends that are very different than what we've taught happens in cattle. Some of these we've published in the last year to year and a half, and several of these are studies that we're just completing right now. And it's very different from what we anticipated when we started these studies. We're building on the work that was actually started. Let's see if I can get this thing to go. Here we go. That was started back in the 80s by work done in Rixenhardt and Utrecht, where we began to look at the ability of herpes viruses to cause local and systemic immune modulation, both stimulation of specific IgA, systemic IgG, but also, and equally important, immune modulation via interleukins, interferons, etc. And as we began to understand more about this local immune system, the ability to control infection rather than moderating severity of disease became the goal of trying to work with mucosal immunity. Many of the studies have been recently published where we began to compare protection provided by systemic BRSV vaccination to intranasal BRSV vaccination, for example, showed a difference in the ability to control infection when we go intranasally as compared to controlling severity of disease when we go systemically. This certainly began then to drive even more of trying to understand the mucosal immune system. So as we began to build on the research that was done initially back in the 80s, followed up with work by Texas A&M and University of Nebraska-Lincoln in the 90s, looking at this local immune system, we looked at several different areas that we began to look at. We wanted to look at the ability of these dendritic cells to stimulate immunity. If you remember that the dendritic cells in cattle are at very high levels in the upper airways. That if we take a look at all the dendritic cells in the body of a calf or in a cow, that the highest level of dendritic cells are in the upper passages. These cells are relentless monitors of what is being breathed in by that animal, and they monitor to see whether or not it's pathogenic. So in their resting state, these dendritic cells have the ability to just monitor for virulence. If they recognize virulence or an imbalance in those upper passages of bacteria, of viruses, they then release and move to local lymphoid tissue where they become very potent antigen-presenting cells. This is done via what are called pattern recognition receptors, very similar to the toll cell receptors that we see in other antigen-presenting cells. The pattern recognition receptors are what have been identified now on dendritic cells that are used for recognizing these patterns of commensal imbalance or of pathogenicity. But more importantly, as we began to look at some of the new work that's been done in the last few years with these dendritic cells, it is what is now being called the dichotomy of the local immune system. For example, recent research has now shown that we have at least 2 different local immune systems. Work that's been published in several papers now is showing that dendritic cells determine the driving of where the mucosal immune system goes. If, when these dendritic cells move, they are adding L-selectin, we'll see specific trafficking to respiratory and reproductive system. That is considered to be one local immune system. If they add alpha E, we see trafficking to the GI tract. And so we now begin to see this dichotomy or different movement of the immune system depending on which dendritic cells are turned on, and thus then as they move to the local lymphoid tissue. We're starting to see this in some of the more current studies that are starting to come out. Recent studies have shown they can vaccinate women intranasally against vaginal strep infections. Some of the recent work with Bordetella in dogs has shown that we get higher protection with an intranasal vaccination than oral, showing this dichotomy of this immune system as we begin to look at what these dendritic cells are doing. Remember, we take a look at the upper nasal passages in cattle. This is some slides from Dr. Amelia Willems. We see that in the upper nasal passages, IgA is our predominant antibody. As we move down the lungs, IgG becomes equally important as a secretory antibody. But we also begin to look at the interferons. Interesting, as we take a look at interferon release For many years, we thought that interferon was good. Some of the newer research that's coming out indicates that at the right levels, interferon can be very helpful in controlling particularly viral infections. But some of the more recent research is indicating that if interferon levels are too high, that we may actually begin to downregulate immune responses, increase severity of respiratory disease, increase our retreat rates, and our mortality rates. We don't know what that right level is. This is one of the areas of research that we still need to do to try to understand what are the right amounts of interferon. May change in different situations, may change in different classes of animals. We certainly don't know at this point. But as we look at measuring interferon with some of the research that I've been involved with in the last 2 to 3 years, we are looking at 3 different interferons. We've been looking at alpha interferon, beta interferon, and also gamma interferon. If you remember, alpha interferon is produced by most cells when an intracellular infection occurs. Beta interferon tends to be released by fibroblasts as that infection continues to go with replication. These are produced very quickly. The primary goal of both alpha and beta interferon is antiviral, although they also do have some immune regulatory, immune modulation abilities. If we look at gamma interferon is produced primarily by activated T cells and also some of the other cells in the body like natural killer cells. These tend to be released a little bit slower. Different from alpha and beta interferon, the primary goal of gamma interferons is upregulation, immune modulation of the immune system with the secondary effect of being antiviral. Thank you, Dr. Williams, for these slides. I wish you could be here. So as we take a look at type 1 interferons, the effects are both local and systemic. Antiviral effects peak very, very quickly if we can stimulate this local immunity and get high levels of interferon in those local areas. Some of the work that was done by Rix and Art years ago so that antiviral activity can occur within 30 minutes to an hour after turn on of this local mucosal immunity due to these interferons being rapidly released. And we get a lot of different antiviral effects that can occur here with these different interferons as they're released. So as we're looking at this local immunity, we began to look at both interferon release as well as specific antigen-specific IgA. So why did we begin looking at this? As we began to look at the ability of these herpes viruses intranasally to stimulate the immune system, one of the questions that began to get raised was, can we use these in dairy cows for immune modulation? And this started a series of studies that were performed in the US in which we looked at the ability of Enforce to work in adult dairy cattle. This was done in 3 dairies in which we looked at vaccinating cows at 14 to 21 days prior to calving. The goal of these studies was really to look at whether or not we could impact respiratory disease in cows post-calving. You can see these herds that we're going into were well vaccinated. Pneumonia wasn't a severe problem in these herds, but was something that we were interested in looking at. What was interesting as we began to do these studies is our biggest impact was not on the respiratory tract. Our biggest impact we began to use as pre-calving was actually reproductive. In multiple sites, we saw significant decreases in retained placentas, decreases in metritis at 0.06, decreases in do not breeds, decreases in culls and mortalities that were consistent among these different herds. This began to have us look at this dichotomy that has been published in the human literature of the respiratory reproductive tract from the GI tract. Understanding that we may be seeing now turn on of respiratory and reproductive mucosal immunity via these herpes viruses, via this dichotomy of the local immune system. And we continue to do those studies today. This was then followed up by a study that really began to change our understanding of this local immune system. And we were asked to do a study that compared the immune response of cows vaccinated 2 to 3 weeks prior to calving to being vaccinated within 12 hours after calving. Now, any of you that do much dairy work know that it's been well documented that the dairy cow post-calving for that 7 days post-calving has got severe immune suppression. This impacts everything from interferon production to lymphocyte function to antibody production. in many of the studies have been done. And so we knew when we started the study how it was going to come out. It was obvious that that cow being vaccinated within 12 hours after calving would have a poorer immune response than the cows were vaccinated 2 to 3 weeks prior to calving. Now, this herd was on a well-vaccinated program. This is the University of Georgia herd. My co-researchers were Dr. Amelia Willems, Dr. David Hurley, and others at University of Georgia, at the University of Georgia dairy herd. What we did with these cows is we split them into 2 groups. There's 30 cows, and they were assigned within blocks, so they were vaccinated at the same environmental time point, approximately 2 to 3 weeks prior to calving or within 12 hours after calving. Nasal samples were taken from these cows twice before vaccination. Then they were taken 2, 4, 7, 10, and 14 days post-vaccination. Now, how do we do this? What we did with these poor cows is we stuck a sponge in their nose and left that sponge in their nose for 5 minutes to attract or to collect those fluids, and then we analyzed those fluids. As all of you know, dairy cows love to have their nose messed with. And after about day 3, these dairy cows did not like us. After about day 10, these dairy cows wanted to kill us when we went in front of them. For the students in here, we did not sacrifice any students to get this study done. But we did get the study done, and we began our analysis. As we looked at serology, a well-vaccinated herd, no differences in our IgG levels as we looked at both BHV1 and BRSV. But when we began to look at the local immune responses, we saw something very interesting. As we looked at the cows vaccinated post-calving, number one, this is the first study that I've done with vaccination in that immediate time post-calving where every cow responded to vaccination. Normally when I go systemically, I have a percentage that won't respond. But what we saw as we looked at the IgA-specific BHV1 antibodies, we saw a significant difference in the cows vaccinated within 12 hours after calving as compared to the cows vaccinated 2 to 3 weeks prior to calving. Opposite of what the literature would indicate that these dairy cows can do post-calving when they're severely immune suppressed. As we look at alpha interferon, because it went intercellular in all these cows, we saw no difference. As we look at beta interferon, you can see which group had the higher, quicker spike. If we look at gamma interferon, significant differences in the fresh cows having a significantly higher level of gamma interferon than we saw in the cows vaccinated prior to calving. Same thing as we looked at our total interferon. Again, opposite of what's in the literature that would indicate that the post-calving dairy cow does not have normal release of interferon. Now, there are some hints that there is shifting of the immune system in these cows. Colostrum certainly is an example of shifting from the systemic immune system to the local immune system. We now know that whether a cow retains the placenta or passes it has a major immunologic component to it with neutrophil trafficking to the local immune system. But nobody has looked in any species at whether or not this immune system that we've measured as immune suppressed has a component of immune shifting. What if, on the day of calving or close to calving in mammals, that part of what we've measured as systemic immune suppression includes immune shifting to at-risk sites, uterus, mammary gland, and I happen to find it here when I went respiratory, accidentally, because of that dichotomy of that local immune system. This is certainly one of the first studies that's shown that we can actually get an increased immune response in these cows post-calving compared to pre-calving cows, and gives an idea that we may see shifting occurring here in this immune system to local immunity. Interesting new work coming out of Dr. Ron Erskine's lab in Michigan State is showing shifting to the mammary gland on the day of calving. So I think we're going to see more information about this shifting or movement of the immune system locally in this postpartum period of the dairy cow. This may explain why immune modulation continues to still baffle us as we're trying to work with this dairy cow. Because if we're trying to give a systemic immune modulator and this cow is trying to shift locally, we may be going against that natural shift. certainly giving us a different way to look at this local immune system. And so as we take a look at the outcomes in the paper that was published about a year ago in immunology and immunopathology, we saw significantly higher responses in the cows post-calving compared to 2 to 3 weeks prior to calving. So what if this immune shift occurs? So the question is, does this also occur then post-trucking? And this then led to the follow-up study that we're just completing right now, that I'll be presenting in a little bit more detail tomorrow with Dr. Amelia Williams and myself and Dr. Brandy Karsh at Mississippi State, where we said, does this occur post-transit in calves? Can we determine or pick up that same immune shift that we saw in these postpartum dairy cows post-transit in calves? Now, certainly if we look in the literature on post-transit immune suppression, we see a lot of different articles. Some of them indicate severe immune suppression and decreased antibody production, etc. Some of them show not much difference. I think it shows the differences that we see in design of these studies, time length of transportation, and multiple stresses that occur. As we take a look at what we did with this study at Mississippi State, we said what we're going to do is we're going to take calves, 50 calves per group, and we're going to put them into 3 groups. One group is going to get vaccinated that are not transported, left at the home facility, and monitored as our positive controls. We took the other 100 calves and we put them on trucks. We transported them for 6 hours, unload them at a strange facility for 2 to 3 hours, re-put them on the trucks, retransport them for another 3 to 4 hours, unloaded them, and then vaccinated them 12 to 24 hours after that transit occurred. So we're trying to now use multiple stressors rather than just one stress of being on the truck, but putting 3 stresses, including different facility, unload, reload, re-stress. Again, we took the same samples. We looked systemically, and we looked at nasal IgAs and also interferon and in these local secretions. On arrival, 24 hours, or in the control group, they're given an intranasal herpes virus, as we did in the dairy cows, to look at this immune modulation ability and to look at whether or not we could determine the shifting of the local immune system. We are still analyzing the IgA and the interferon levels, but I want to show you the IgG levels. Significant differences in IgG levels as we take a look at our vaccinated from unvaccinated calves. But you'll see here that we do have an increase in the immune response in those calves post-trucking. Not significant, but certainly we're seeing this trend towards a better immune response post-trucking, opposite the literature that after multiple stresses, we should have a decreased immune response. As we look at the BRSV, even more significant, we begin to see significant differences here between the animals vaccinated post-trucking via the animals that were vaccinated untrucked, giving us a hint, like we saw in the dairy cows, that there may be some shifting occurring towards this local immune system post-trucking. If we take a look at all the studies that have been done to date that looked at post-transit immune suppression, postpartum immune suppression in the dairy cow, these studies have all been done looking at systemic immune system. There are very few to no studies that have been done looking at immune responses locally in that post-stress period. These are some of the first studies that have begun to examine what's happening with that local immune system during that post-stress period, and has given some indications that there may be some shifting going on there. Certainly a lot more work that needs to be done as we try to understand what is the proper balance of this shifting. What is the proper levels of interferon that we need to get? Work from Dr. Joe Cummings that was published years ago showed that too high of interferon levels can actually decrease intakes, increase chronics and deads. What is the right shifting? Is this genetically determined? Is that what makes some animals more resistant to disease? Is the animals are better at doing that shifting? Certainly a lot more that we need to understand. The other thing that we need to understand as we take a look at this information is the timing may be as critical as the level. So for example, in these dairy cows vaccinated day of calving, in these cows vaccinated post-transit, yes, I get a higher immune response, but is my timing incorrect? This is certainly part of what we have to understand. A large study that we have going on right now, 1,100 dairy cows per group are comparing the clinical outcomes, giving it 2 to 3 weeks prior to calving or day of calving to see whether or not that higher response relates to better clinical outcomes. I may get a higher response, but the timing may be wrong for impacting retained placentas, for impacting metritis, impacting culls and deads. And so we've got to look at not only the level of the response, but also the timing of the response as we try to understand more of mucosal immunity and how do we work with this as we're trying to design future studies, future vaccination protocols, and even immune modulation. Do we look at immune modulation being locally administered? And then does that timing become important as we've looked at some systemic immune modulation studies that have been done? And so as we take a look at the shifting, certainly is an area to try to understand more. It's going to drive, I think, more studies in the future to understand how this can impact how we work with this postpartum dairy cow, this post-stress wean calf, trucking calf, etc. And can we work with this local immune system in more ways to work with both the dichotomy of the immune system, but more importantly, the shifting that appears to be occurring opposite of what we've traditionally been taught about post-stress immune suppression in these cattle. I want to finish by talking about a brand new study that we've just finished that we're going to be submitting for publication in the next month that continues to build on some of the colostrum research that's been done through the years as we look at colostrum's ability for both immune modulation, immune training, and also then health and future performance. We know that colostrum has the ability to do a lot of different things, including what the white blood cells do. Interesting in some more recent research by Dr. David Hurley and also work done out of Virginia Tech has shown that these maternal leukocytes don't only transfer antigen-specific immunity, but they also stimulate development of antigen-presenting capacity. What we've seen over the last few years has been a discussion about what are the correct levels of colostrum to put into these calves. What is the right total proteins that we should be using for monitoring these calves for good colostrum transfer? We know from some of the new work that's being published that colostrum has both short-term impacts on health, also long-term impacts on growth, health, and performance in these animals, everything from weight gain and feed efficiency to reproduction and longevity in the herd. But traditionally, we've said that if we can get total proteins of 5.5 or above, that's generally considered adequate. A study done by Art Donovan at University of Florida would indicate that we should move that further, that we should go to 6.0s. However, Dr. Donovan's study was done in a very limited number of calves and has raised a lot of concern about whether or not that level is adequate. And so we did a study that we've just completed where we looked at total proteins in 39,000 calves. In these calves, we looked at total protein levels from under 5, 5.0 to 5.5, 5.5 to 6, and then 6.0 and above. We looked at dehydration. This study is being considered 8.99. I will tell you that what we are doing right now is analyzing this a little bit further and looking at 6.5 to 7, 7.5 to 8, etc., so we can cut this even more for publication. But what's interesting is that we consistently see as we go from less than 5.0 to over 6.0, we continue to see significant decreases in the proportion that died, indicating that while 5.5 has been the standard for many years, that if we can consistently get 6.0, that we will have a significant decrease in our proportion that die. You can see this is the exact same thing here. We see a little bit of bounce, but again, we see a decrease as we go to 6.0 for our proportion with diarrhea. Same thing as we take a look at the proportion that require IV therapies for treatment, proportion with joint ills, and the proportion with pneumonias. I believe that as we take a look at this large study done both in Holstein and Jersey calves, that this gives us a good indication that the new standard is going to move from 5.5 in these dairy calves to being over 6.0. I wish I could tell you today what this looks like at 6.5, but we are analyzing that data right now. And so as we take a look at where this is going, as we take a look at the future, I think there's going to be tremendous opportunities. We learn more about mucosal immunity to use this. This certainly is becoming more the trend as we look around the world at trying to use less needles in cattle and try to use this local immune system, both orally and intranasally. This will give us some ideas on when to use vaccines orally, when to use them intranasally, depending on the disease we're trying to control. This has certainly given us some new insights into how to work with these cattle during stress periods. A paper that we published about 1.25 years ago looked at post-transit cattle comparing intranasal arrival vaccinations to injectable, and we were able to show statistical and consistent improvement in health parameters when we shifted from using everything going systemically. And we use this local immune system for some of this immune modulation as well as protection. Certainly every time we do these studies, it raises as many questions as it answers. Because a lot of this work has not been done before, we don't have measuring points to even start. So I do interferon studies and I say, well, I don't know what the right level is. All I can do is look at differences from baseline. What is the right protective level for IgE or IgA? Probably varies by challenge. We don't know. But there certainly is going to be more questions as we do more of these studies. But gives us a whole new way to begin to look at postpartum immune suppression, post-stress immune suppression in cattle, to evaluate this shifting to understand how we can work with these cattle in the future. Questions?
Thank you very much, Dr.
Dr. Akihiro, do you want to wait till after we finish for questions?
Okay.
After Dr. Shingos?
Thank you very much, Dr. Cortese. Would you like to have time for Q&A?